Today we're going to continue our work with rational exponents, and just kind of remember that if we have a to the m over n power, a rational exponent, that bottom number tells you the root and the top number tells you the power. We're going to be simplifying some variable expressions with our rational exponents today. In example 3a, I'm going to do two different pieces here. I guess part A for example 3a. We are going to simplify the 6th root of 10 times the cube root of 10. And just looking at this, you might be thinking, well, I can't actually multiply these because the index is different. I have a 6th root here and a cube root here. Let's think for a second, though, what this means if I have a rational exponent. The 6th root of 10 means 10 to the 1/6 power. And the cube root of 10 means 10 to the 1/3 power. Looking at our exponential form now, my exponent properties from Algebra 1 tell me that if I have the same base here, where I have powers that are multiplied together, I can add the exponents. So this is really 10 to the 1/6 plus 1/3 power. And if I figure out what that is, 1/6 plus 1/3, then I can write this as a single term, if you will. So I have to figure out 1/6 plus 1/3. But remember that to add fractions, I need to have common denominators. 1/3 is 2/6. 1/6 plus 2/6 is 3/6, which is also 1/2 if you simplify. So my 6th root of 10 times the cube root of 10 really ends up being 10 to the 1/2 power, which is the square root of 10 as my final answer. Okay. Now as far as like simplifying goes, I don't want to have any rational exponents in my final answer. Okay. So I'm going to write a couple things over on the side here. So we're simplified if no rational exponents, no negative exponents, no radical in the denominator, and our radicals are combined. If possible. Like in this case, it didn't really seem like this is possible at first because I have the different indexes. But if I use those rational exponents, then we can. So these are the things I'm looking for to see if something is simplified all the way. Okay. Can't have any rational exponents, can't have any negative exponents, no radical in the denominator, and combined radicals if possible. So if all of those things are true, your final answer is simplified. All right, let's look at the second part in example 3a, part B of example 3a. Let's do the 8th root of x to the 5th power over the 5th root of x squared. And again, I have something where I have different roots. So I don't know if I really can do anything here, but let's think of what each rational exponent is, and then maybe I can do something. This 8th root of x to the 5th is x to the 5/8 power. Because remember that top number is my power, the bottom number is my root. Over, this would be x to the 2/5 power. And this still looks pretty messy, but I have x to a power over x to another power. Our exponent properties tell us that we can subtract these powers. So really, I need to figure out what is 5/8 minus 2/5. Well, Again, I need a common denominator. And my smallest denominator that I can think of is 40. Oops. So 5/8, if I multiply everything by 5 here, is 25 over 40. And 2/5, if I multiply everything by 8 here, is 16 over 40. 25 over 40 minus 16 over 40 is 9 over 40. So that gives me x to the 9 over 40 power. Which simplifies, because I don't want a rational exponent in my final answer, to the 40th root of x to the 9th.